Hey guys, we're going to go over the COMSOL program, which is basically a simulation of different fluid stuff. And today we're doing step flow. So this is kind of a basic overview of what we want to do. And we're going to learn structures of physics, geometry, material boundary conditions, computational mesh, simulations, and visualize the results. And these are the visualizations. But basically what we want to do is I have a paper over here that goes over the steps of what we're going to do. And these are the steps. It seems like a lot, but it's a pretty quick simulation. And it's a very basic simulation with COMSOL. So what we want to do is, we want to learn important points and ideas, like I've said before, the physics, the geometry and dimension, the computational mesh, the boundary and conditions, that's inlet and outlet, and how do we visualize these. So for visualization, we're going to do a pressure control, which is right here. We're going to do a streamline, which is right here, a vector field, and these are obviously vectors. You can't really see it here, but I will scroll in when we get to that point in the simulation. And then the velocity control. And these are all based off of a water model. And as you can see, which I'll even explain later, but the red is more velocity, the blue is less velocity. So basically how to get to the COMSOL program, you want to go into VLabs if you are a UML student. If not a UML student or a student that has the program, you have to download it. But VLabs, you can either enter it through, VLabs through the app, which I'll be using, or you can simply just go online. So for the VLabs, you want to go into, which I already logged in just because it takes a long time to log in, but you'll log in and you'll open this window and you want to press General Engineering V2. And then when you click on that, you'll open up to this window right here. And then you want to go to the start menu down here and you want to scroll all the way down till you see COMSOL Multi-Physics 6, this folder, click the folder, and then you just want to simply click this first COMSOL Multi-Physics 6 program. That will take a while, so please pause the video and let it load so that you can go into doing the simulation. So I kind of already started the simulation, but what I'm going to do is I'm just going to simply press a new simulation, and after you log in to this and you into VLabs and you have it open, what we're going to do is we're going to press Model Wiz. That is right here. Again, Model Wizard. And then you have all of these things. For this simulation, you want to press 2D. So again, Model Wizard, press here, 2D. All right, so now it will open up to here. And what we want to do is we want to specify the flow. And how you want to do that is you want to press the fluid flow. And it's going to simply open here. You want to go to single phase flow and you want to press laminar. And you're going to add it. So again, fluid flow, single phase, laminar flow. All right, and then you're going to add it. And now that should add. And now you want to press the study button down here. So again, fluid flow, single phase flow, laminar flow, add, press the study. Now once you're in this study here, select the study. We want to do a stationary study. You can do time-dependent studies and all sorts of things, but what we want to do is we simply want to have a stationary study. And then you're going to say done. You do want to save your things. You can just save this to anything. I'm just going to simply save it as 1. But you do want to save it so that when you keep working, it will save, but you want to constantly save it so that you don't lose your work that you've already done. So basically, once you are done selecting this type of study you want to do, it will open up to this window. So we want to specify the geometry, and how we're going to do that is we're going to press geometry 1. In most cases, it will already be open to that, but it's, again, geometry 1, clicking that, and you're going to go into the model. And geometry 1 is under the model builder. And a setting window will open. It'll be here, right here, and you simply want to press the millimeters, and that's good. So again, look to the left side of the window to the model builder, and it will say geometry 1. Click the geometry 1 if it's not already selected, and change it to millimeters. So what we're going to do now is we're going to actually build the geometry, and what you want to do is go back to the geometry 1, right click it, and we're going to press rectangle. So you can label this whatever you want. I'm going to simply keep it as rectangle 1, but you can basically label it whatever you want. And I just got rid of that side window just because it's not technically going to be open to that when you open it, just because I already started the simulation beforehand. That was something I'm doing later, and you will see it soon. But simply, you can do all sorts of different geometries, so solid or curve. In this instance, and rectangle. So in this instance, we're obviously doing a rectangle, but what we want to do is we want to change the width and the height. The width is going to be 150. Height is going to be 10. And now, if you have like positions or anything, you can change your positions. You can do your angles. You can do different layers, like your layer thickness. You can do results. So you can do all sorts of things in this. But simply what we want to do is, like I said again, go back to Model Builder, go to Geometry. You're going to right click, press Rectangle. You're going to open up this rectangle. 1 is going to open up in the settings. You can change the label, but what we're going to do is, like I said, right click Geometry, press Rectangle. This settings will pop up. Slide all the way down to where it says width and height, change the width to 150 and the height to 10. So now what we're going to do is we're going to build the selection. So now obviously our rectangle is right here, and our building our geometry is not done yet. What we want to do is do a cutout, which is basically going to be right here. So what we're going to do is we're going to right click the rectangle, and then we're going to duplicate it. So now it will duplicate, but we don't want the same dimensions in this because we want to cut out only a selection of the first rectangle. So what we're going to do is we're going to change these dimensions to 20 for the width and 5 for the height. And then that, again, I said there's different things, but again, right click on rectangle 1, duplicate it, and rectangle 2 should come up in here, and you're going to change the width to 20 and the height to 5. Now we're going to do build selection, and our second rectangle's here. But it's not cut out yet because we want to actually cut it out. So you see all these tabs up here. You want to press geometry, and you want to go to this Booleans and partitions drop down window, and you want to press that, and you want to press difference. So now the difference will open up on here, and we're going to simply press which one is going to be the object to add. The object to add is the big rectangle, and then the object to subtract is the small rectangle. Like I said before, go up to geometry, go here to the drop-out menu, press difference, and then you'll open up here. You're going to press this. For this, you're going to press the little one, and then you're going to build selection. And now this is geometry you want. It cut it out. So now we're done with geometry. So we're going to move into material, which is right here. So you're going to go back to the model builder, material, and you're going to click the material that we want. But obviously, so model builder, material, right click, you're going to go add material from library. And the only difference is this new pop-up window, which is add material. You're going to build in a material and you're going to press air. You can either double click it or you can say add component, which will add the component, will load, now it's here. So like I said before, go over the model builder, press material, right click it. You're going to right click it here, add material from library. This will pop up, build in air, and then select either double click or add it with the button. So now it's added. And since we have, so now that we added the material, we want to specify physics, but because we already specified the physics, which is the laminar flow, which is obviously you can see right here, we don't need to specify the physics necessarily, but we do need to specify where the physics is being applied on the geometry. So what you want to do is press the laminar flow, right click it. You want to press inlet. What you want to do is press this vertical line going downward, and we'll press that. So now it is added, which will be added to this little box right here. And then we want to go down to the velocity, and we want to press 0.5. And then that's added. We want to go, so we have an inlet, which means then we're going to need an outlet because it needs to go in one way and out the other. So obviously our outlet's going to be the opposite side of our inlet. So we once again want to press laminar flow, right click it, press outlet. And what we want to do is simply press the outlet. We don't need to do anything down here. We can just keep it there, but there are different things for different simulations, but for the simulation, we don't need to do anything for that. So now we're going to do the mesh part of this, which you're simply going to click the mesh, which is under the model builder. As you can see, model builder, you got it. All right. And then mesh right here. So you can do a user control mesh, but we're going to do a physics controlled mesh, and you can do all sorts of element sizes. We're going to do the normal, but you can do coarse, extremely fine, but we're going to use normal. So what you're going to do is you're going to build all. And so now it's going to simply go here. So I didn't say it earlier, but I am using a mouse. It makes it so much easier to do all of the controls on it, like to zoom in and stuff. But as you can see, the mesh is here. And you can zoom in and see the mesh. So basically what we're going to do after this is we did the mesh. We actually want to press the study, and we want to compute this study just because this is the actual simulation. What we did was just set up the simulation. So you want to compute. Like I said before, press mesh, study, compute. It's going to load a little bit, but it should compute everything that we want. Okay, so it should open up to this window. If you want to see this like bigger, you can just click off the add materials window. But this is the velocity magnitude. As you can see, what I said before, red means higher velocity, blue means lower velocity, and you can see it on this scale on this right side right here. And this is simply, if you scroll down, it's the results. So we have the velocity and we have the pressure. And this is the pressure. You can see that, reds are higher pressure, blues are lower pressure. And we're just simply looking at the scale. In our instance, we can just see that we have a lot of blues, so we don't have much pressure. All right. So what we want to do is kind of do a velocity vector. So you're going to go over the model builder. You're going to click the velocity, right click it, and you're going to see that there's the surface, which we already have. That's the surface. Now we're going to do arrow surface, and you see the arrow surface here, and we have 15, 15. We can keep it there. So we're going to simply just plot it. So you can't really see it. I can kind of scroll into it, but as you can see, they're vectors. So you can change how many you have, and you can change the size here to larger, smaller. You can do all sorts of things with that. So in order to see the vector, you can go into surface, right click it, and you can disable it. That way you don't actually have to delete it. And you can also, turn off your arrows surface, but simply now you can see your vectors easily. So since we already have the vectors and the velocity surface, what we want to do last is do a streamline. So again, you're going to go to the model builder, go to the velocity, right click velocity, and you're going to simply go down to streamline, press streamline. It should open up here. And for streamline, we want to scroll all the way down here, and it has this box, which again, you've seen the box already with the previous stuff. It just simply says what boundary this streamline is going to come off of. We want to press right here. And you have all sorts of things here. On select boundary, you have magnitude controls. And then you have uniform, mesh-based, all sorts of things. So, well, right now for the simulation, we're going to do on select boundary and uniform. So you're going to plot. So as you can see, it doesn't give you that difference. The difference here, but that's simply because we pressed the on select boundaries in uniform. So because of the simulation we chose, this is what it looks like. But to fix that, if you want to see like the difference here, like if you want to see what the difference in the streamline is on this surface, as you can see, like, yeah, if you streamline it from here, you're not going to get that, but you want the difference on here. You're going to press the on select magnitude control, and what we're going to do is we're going to plot, and now you can see the difference here from the streamline. So that's basically all we're doing for the simulation. This is pretty simple simulations that we did with COMSOL, but because we chose, the different, streamline, it can show different things. As you can see, this program has so many capabilities. So, like I said, pause it as you go along so you can follow along. I do repeat over and over, but we went over the physics, the geometry and dimension computational mesh, the boundary conditions, and how to visualize it. I would take screenshots while you go, as well as save it at the end. But that's pretty much all that's for this simulation. And thank you for listening.